Dear students, in earlier lectures, we have seen what is determinant, how to solve, what are the properties of determinant, examples on properties of determinant, Cramer's rule for two equations, two variables, and also for three equations, three variables, right? So, the basic structure of determinant is now we are studying as a matrix. Okay, so to matrix means in a determinant, what was there? There was the structure of numbers in square form enclosed by vertical bars, but in a matrix it is enclosed by square brackets. Look at here. Okay, you can see here, this is what? Square brackets. This is square bracket. Similarly, another example, this you can look at here. And in determinant there was a square arrangement. In matrix it may be a square arrangement or a rectangular arrangement. ये rectangular है, बराबर है, ये square arrangement है. Is that clear? So, and it is symbolic notation of a matrix enclosed by square brackets. So, before starting this lecture, please you subscribe this YouTube channel, Maths Clinic Counseling Center, if you are not subscribed yet, so that I will get the motivation for preparing the more lectures in future. Also, you can comment on a lecture when you watch it in a comment box, so that I will get the idea for further improvement. Is that clear? So can we start? Okay, so let us see matrices. So first of all we will discuss who discovered these matrices. So this, look at the photo, Arthur Kelly. Okay, born in 1821 and left out 1895. Okay, Arthur Kelly. So he discovered the matrices. Okay, this is Arthur Kelly who discovered the matrices, right? And look at here, in the year 1860, matrices is discovered in the year 1860. Means what? 1860 means 40, 140 years and 25 means 165 years back. 165 years back. Is that clear? So matrices were discovered by Arthur Kelly. Now let us see what are its application. Matrices. So matrices are widely used in various disciplines, various areas of the mathematics. Okay, so matrices is very useful in many branches of applied mathematics. Okay, in many branches of applied mathematics, as a tool to find a solution, to various problems. For example, algebraic and differential equations. Algebraic means the system of linear equations in three variables, three equations. System of linear equations is two variable, two equations, right? Differential equations, ordinary differential equation, partial differential equation. Is that clear? So this is widely used the mathematics. Mechanics. Okay, in mechanics also there is a wide use of matrices. Okay, to find various forces and other things, right? Then you see theory of electrical circuits. In electrical it is widely used. Okay, for in electrical it is used as a image processing to make the given figure dark, to make the given figure bright than as usual, right? So that is the inversion of image. Then nuclear physics, it is used in nuclear physics also. Now aerodynamics and astronomy. Okay. Now one more area is there. Have you heard the name MATLAB? MATLAB. It is a matrix laboratory. It is what? Matrix laboratory, wherein all calculations can be done in even differential equation, in even simultaneous equations, the system of linear equations, system of heat conduction, all applications are solved in matrix laboratory, wherein data is saved in the form of matrix. Is that clear? And therefore MATLAB is nowadays widely used to solve the mathematical applications. Okay. And similarly computer applications. Computer applications. In a computer applications, the every while programming, in computer programming, the data stored is always saved for programming in the form of matrix arrays. Is that clear? And therefore the matrices use is widely used in the form of in computer applications. Is that clear? So now before that we just revise what we learned as a determinant. Okay. So what was determinant? Determinant is what? A square arrangement of numbers in rows and columns enclosed by vertical bars. Is that clear? Square arrangement of numbers enclosed in rows and columns. Is that clear? So we have studied. Can you remember? Look at here. 1, 2, 3, 4. This was determinant. Is that clear? Another 105, 207, 112. Is that clear? So look at here. Here 2 rows are there, 2 columns are there. Here 3 rows are there, 1, 2, 3, and 3 columns are 1, 2, 3. Okay, and there was square arrangement enclosed by what? The vertical bars. Vertical bars. Is that clear? So this is determinant, and it was denoted by capital alpha bet. Determinant can be evaluated. Now this determinant was, for example, if we solve this determinant, it is what? 1 into 4 minus 2 into 3. That is equal to 4 minus 6, and so final answer is minus 2. Means determinant can be evaluated into a single numeric value. Single numeric value. Is that clear? So now entries. What was entries? Entries means what? Entries. Look at here. This is the determinant. So the all numbers enclosed by inside the vertical bars are called the entries. Entries. Entries are 1, 3, 5, 1, 3, 2, 3, 4, 1, 0, 5, and 2. Is that clear? These are called entries. Now what are columns? Columns. Columns are the vertical lines. Vertical lines. Okay, that is 130, 345, 212. Rows. Rows. What are rows? 132, 132, 341. बराबर है? So that horizontal lines or arrangement. Is that clear? So there are 3 rows and there are 3 columns. Is that clear? So these are rows and columns. Is that clear? Then what is order? Order is what? Number of rows into number of columns. Okay, is order of determinant. Okay, so here above determinant order कितना है? Is 3 rows है, 3 horizontal lines और 3 columns है, so 3 by 3. Now in the first line we have written 2 determinant. The first determinant was order of, what is the order? Here order is 2 by 2. Is that clear? So that is the entries, order, and now we come to this today's main topic, that is what is matrix. So in a determinant, earlier we discussed that it is a square arrangement of numbers. In matrix, it is not only square but it may be a rectangular arrangement. Okay, a rectangular arrangement, and you know that every rectangle has two possibility. Either it is unequal number of rows and columns or equal number of rows and columns. If equal number of rows and columns, then it will be called as square arrangement, and unequal, rectangular arrangement. Okay, so it may be two types, that is square and rectangular. Is that clear? Arrangement of numbers in rows and columns enclosed by square brackets. Previously in determinant it was enclosed by straight line, vertical bars. Is that clear? So that is a matrix. We can write some example. Look at here. This is square bracket. Now I am writing here first row 1, 2, 5. Second row 0, 1, 2. Okay. So how many columns are there? Rows 2 or columns कितने 1, 2, 3. Okay, unequal है. So it is possible. Okay, because rectangular arrangement we said. Okay, so that is what a matrix enclosed by a square bracket. Is that clear? So that is a matrix. Then we see entries of the matrix. Entries. So all numbers within square bracket called as entries. Is that clear? For example, 6, 2, -1, -2, 0, 5. These are what? Entries. Isn't it? So entries हो गई. Then you see, okay, again here rows. How many rows are there? Rows 2. Columns, how many? 3. 1, 2, 3. So column 3. And therefore, what would be the order? Order is what again? Number of rows into number of columns. Okay, and therefore number of rows are 2. Number of rows are columns are 3. 2 by 3. Okay, so therefore this is the order of the matrix. Okay, so it is denoted by capital alphabet. Let A is a given matrix. A equal to, suppose I am writing 1, 2, 3, 3, 1, 5. Okay, 2, 6, 4. Okay, 0, 1, 2. This is the matrix I have written. So how many rows are there? 1, 2, 3. So 3 rows are there. And how many columns are there? 1, 2, 3, 4. So A is a matrix of order 3 by 4. A is a matrix of order 3 by 4. Is that clear? So that is the order of matrix. Then you see the order of given matrix. This earlier matrix is what? 2 by 3. We already discussed this. 2 by 3. This 2 by 3. Okay. Then you see standard definition of matrix. So the standard definition, a system of m into n numbers. M into n numbers means what? M number of rows and n number of columns. The total entries would be m into n. For example, in previous slide if we take, look at here. The order is 2 by 3. So 6 entries would be there. So let us see how many entries are. 1, 2, 3, 4, 5, 6. So number of entries in any matrix is equal to the number of rows into number of columns, and therefore we said in a standard definition that a system of m into n numbers arranged in rectangular form along m rows and n columns and bounded by square bracket. In bounded, or you can write enclosed by square brackets. this square bracket is called a matrix of order m by n. Okay, if m rows, in place of m rows we can write, suppose we write in place of m rows, if suppose we write k rows, and in place of n columns, suppose that it is l columns. So what would be the order? K by n, k into n. Is that clear? So that is the order. Now a matrix is also denoted by single capital alphabet like A, B, C, etc. Any capital alphabet. Is that clear? So that is a this is the matrix. Okay. So what is the order here? Order of matrix A is equal to, what is the order? Number of rows. How many number of rows are there? 3. Right? 1, 2, 3. Into number of columns. 1, 1, 2, 3. So 3 by 3. Okay. Is that clear? So that is number of rows and number of columns. Okay. So rows means these are columns. Okay, C1, C2, C3. These are rows. R1, R2, R3. Okay, R stands for row. So R1 means first row, R2 second row, R3 third row. C1 first column, C2 second column, C3 third column. Is that clear? So that is the number of entries. And so what is the order here? Order is equal to what? 3 by 3. For example, I write now B is another matrix, that is 1, 2, 0, 0, 1, 5, 2, 3. Okay. So what is the order? Order is equal to, how many rows are there? 2. How many columns are there? How many columns are? 1, 2, 3, 4. So 4. So order is 2 by 4. So understand what is order and column. Now thus the matrix, any matrix can be denoted by this. Okay. Now look at here. Now here you just see A11, A12, A13. Now what is the position of A11? What is position of A11? Tell me. A11. Where does it belong? It belongs to कौन से रो में? पहले रो में. और कौन से कॉलम में? फर्स्ट कॉलम में. Is that clear? A12 कौन से रो में? फर्स्ट रो में. कॉलम कौन सा है? सेकंड कॉलम है. ओके. देन is that clear? Then A22 अगर आपने लिया तो व्हाट इज इट्स पोजीशन? A सेकंड रो में है और सेकंड कॉलम में है. Is that clear? So that is the, in general, matrix can be represented by these unknown notations. Okay, A11, A12, A13, A1n, A21, A22, A23, A2n. AM1 means it is mth row, first column, mth row, second column, mth row, nth column. Is that clear? So that is the matrix. Now what is the order of this matrix? Number of rows. How many number of rows are there? 1, 2, 3 up to m. So number of rows m. Number of columns कितने हैं? n. And therefore order of matrix is m by n. Is that clear? Order of matrix is m by n. Is that clear? And now in general, ये जो लिए है A11, A12, A1, we can write in general aij. We will discuss what is aij. Okay. So aij. So therefore, the given matrix A can be written as the square bracket aij. Okay, whose order is m by n. बराबर है. Means I will take the values 1, 2 up to m, and j will take the values 1, 2 up to n. Is that clear? So in this way we can form the matrix, okay, of m rows and n columns. So symbolic notation, representation of matrix. So let A be a matrix of m by n order. So m rows and n columns. यहाँ पे लिखा है हमने m rows n columns. Okay, and then the matrix is represented by aij with m by n. देखो यहाँ पे लिखा है हमने. Okay, so this is the matrix where I is 1 to m. देखिए यहाँ लिखा है. Okay, and j is 1 to n. Is that clear? Now from this matrix we can specifically write. Look at it. What is a11? a11 is the element of first row. एलिमेंट ऑफ फर्स्ट रो एंड पहला डिजिट 1 है फर्स्ट रो, सेकंड डिजिट 1 है तो फर्स्ट कॉलम. ओके, सो टेल मी व्हाट इज a22? इट इज अ एलिमेंट ऑफ सेकंड रो एंड 2 means second column. Is that clear? So a22. What is a32? a32 first letter, first digit 3 मतलब third row, second digit 2 second column. तो element of third row and second column. समझ में है? Okay, likewise we can write what is this? element of fourth row and fourth column. Is that clear? a41. Then a52. a52 is what? element of fifth row, बराबर है, and 2 means second column. Is that clear? Then a3n. Now tell me, first digit 3 means third row, last digit n means nth column, means element of third row and nth column. Is that clear? So similarly aij. So what is aij then? So it is element of ith row and jth column, because first digit is denoted by I and second digit is denoted by j. Okay, so what is n? So am is element of mth row and nth column. Is that clear? So in general it is general notation of the matrix representation. So you understand, this was the basic about the matrices. Is that it? How matrix, what is matrix, what is determinant, what is the difference between matrix, a major difference between matrix and determinant, because matrix cannot be evaluated, whereas determinant can be evaluated into single numeric value. Determinant is only square arrangement. Matrix may be square, may be rectangular. Okay, and therefore, and determinant enclosed by square bracket, matrix enclosed by square brackets. Is that clear? Determinant enclosed by vertical bars and matrix enclosed by square brackets. Is that clear? So that is the main difference. If you understand this lecture and if you like it, please subscribe the YouTube channel Maths Clinic Counseling Center. Like the video and share it to the students, those who are in need. Is that clear? Thank you. Thank you very much.